Hi, everybody. So again, we're looking at the multiple choice questions from the practice AP packets I'd given you guys. We're going to start on the no calculator section. So that's section 1A is what it's called on the front cover. I think I got the questions here pulled up. So as soon as you have one that you want to talk about, just fire away a number and we'll just kind of dive right in. But it's like you guys lead the way and we'll talk through strategy or like how I would approach something or any of that stuff. $30, yeah, sure. The last one, huh? Well, 30 should be the last. That's it, right? All right. So this is the idea. So it says, for a certain continuous function f, the right Riemann sum approximation of the integral from 0 to 2 f of x dx with n subintervals of equal length is that expression for all n. What is the value of that integral? So what I'm going to do is I'm going to use the limit definition of an integral, which is the limit as n goes to infinity of the sum of delta x times f of xi. Okay with that? That's just the limit definition. This right here, this part, well, I guess it's like I equals 1 to n or something. This is just our Riemann sum. Okay, that sum where we're multiplying, the height of the rectangle by the value of the function, by the width of our subinterval, that is a Riemann sum right there. Bless you. So because that's the Riemann sum, we're told in the problem that I can approximate that with this expression. So I can just drop that Riemann sum and input that. So this basically just turns into a limit problem now. I just need to find the limit as n goes to infinity of this expression. Well, I notice here that the numerator is degree 2 and the denominator is degree 2. So this should just be the leading coefficient over the leading coefficient. Violet, you happy with what we've done so far? So if I look at the numerator, the leading coefficient is going to end up being like 2 times 3. And in the denominator, the leading coefficient is just going to be 1. So my answer should just be 6. So the key here was remembering that like limit definition of an integral. Now, I didn't even, I mean, if I just kind of remembered it, like it's the limit as the Riemann sums get infinitely thin, that's going to be good enough, because it would just tell you that, like, okay, I'm just doing the limit as n goes to infinity of this thing. But that's the idea. There's no, I don't think, any way of kind of getting through that without that limit definition. Like, you had to have it. At least understand enough to be like, still, you know, like the integral is the same as the Riemann sums getting infinitely narrow. Yeah. Yes. Oh. 23, sure. Let's see here. Okay. Oh, yes, one of these non-volume of rotation volume problems, right? So it says the region enclosed by the graphs of y equals x squared and y equals 2x is the base of a solid. For the solid, each cross-section perpendicular to the y-axis is a rectangle whose height is 3 times its base in the xy plane. Which of the following expressions gives the volume of the solid? So I'm going to start just by sketching a little picture of what this is going to look like. So there's y equals x squared and y equals 2x. Everybody's okay with me just being able to sketch those in really quickly, right? No big deal. And it says that my cross sections are going to be perpendicular to the y-axis. So that's like going to be the base of my rectangle then. So far, so good? Okay. So the first thing I'm going to do when I look at this problem is I'm going to look at my choices and try to make this a 50-50 problem as soon as I can. Sound good to you guys? And the way I'm going to do that is I'm going to use the bounds for my integral to figure out which ones I can eliminate right away. So I know if I'm integrating or if my cross sections are perpendicular to the y-axis, I'm going to be going from 0 to b, whatever that b is, where the b is going to be the y coordinate at that intersection. So first things first, I want to find that intersection, because that's going to make this a 50-50 problem for me, which I love. If I can take all these problems and knock them down to 50-50, I'm sitting at, I feel real good about 50% on the multiple choices at worst, because now you're living in like three land, which is a pretty good minimum basement to be at. So to do that, I'm just going to take the x squared and set it equal to 2x. And then just solve that. So I know the x coordinates for the intersections are at 0 and 2. And then if I just plug that 2 into either one of them, I see that this point is 2, 4. So that b value is 4. So right away I can eliminate c and d as possibilities. So far, so good? Okay. What I want to do now is try to figure out which one I want between A and B. The only difference between A and B is one is a plus and one is a minus. Everybody see that? So I'm going to think about B this way. So B is going to be a x value, or it's going to be the difference of x's, right? Let's say that this point is like x2, y2, and this point over here is like x1, y1. I shouldn't have used B there. This B is going to be just like x2, minus x1, right? So I'm going to go with A. So on a problem like this where I don't actually have to do the computation, I just have to pick which presentation is the correct one. I don't know if I'm going to build the whole thing out because of time, right? So first step is I'm going to look at it and go, okay, I can 50-50 this either by looking at the bounds of integration or the variable of integration. Notice that 2 of them are dy and 2 of them are dx. I could have immediately, because I'm doing cross sections perpendicular to the y-axis, knew I was going to do a dy problem and eliminated the 2 dx's. But that's the gist of it, of what I would do on that, Paulo. Does that make sense? Yeah. So again, you can do the whole setup and solve the equations in terms of y's and do the whole shebang, but you don't. If you look at what you have here, you don't need to do that. Just need to decide whether am I adding or subtracting, am I integrating with respect to dx or dy, with respect to x or y, and that should really be enough. Does that kind of make sense? In a timed test like this, where time is going to be maybe your most valuable resource right after how much knowledge you have, making good choices about how you're spending that time really is going to help. When you get to the problems, it's I just don't know what to do with this, where I'm going to need some time to kind of grind away at this. If it's something okay, I know how to do this, but all I need is the setup, and the correct setup is in the answer. I'm just going to start eliminating the things that can't be correct. And if I can get it down to 50-50 at minimum, I feel pretty good. If I can get it down to okay, it's got to be that one because we need to subtract instead of add. Look at the differences between the answers on a setup problem and really kind of take advantage of what they're giving you there. You kind of see what I'm saying? I wanted to point out that I did over the break, I put up the practice exams for 2018 and 2019 along with the AP's keys and my worked out solutions to things also. So if you're looking for some more practice and just be how would I, this, if I run into this type of problem, can I do this without doing the whole problem, right? Especially on the multiple choice. If you can get away with getting the answer without doing the whole problem, that's lovely, lovely, lovely situation to run into. Because these are, in reality, I think you have 30 problems in 60 minutes. Should be 2 minutes a pop problems. Now, I promise you there will be problems on here that realistically cannot be done in under 2 minutes, that you need to bank some time on some easy ones so that you have time when you run into something woof. This is just going to be some time. There's a lot to kind of do to sift through to get to the correct answer. But try to have especially the first half of the test, try to keep an internal clock going and not spend more than 2 minutes on a problem initially. I would want to, if I can get down to 50-50 or 3-1, if I can eliminate one choice in 2 minutes, and that's as far as I can get, I'll do that and then just kind of circle back and see if I have some more time to come at it. But I'm not gonna, the first half of the test, I don't want to spend 5 minutes on any question. I want to make sure I get all the stuff done that I know how to do quickly done, and then get a 2 minute shot at every question. Then I'll circle back to stuff if I have to make some guesses at the end. I'm okay making guesses if I can reduce the number of choices. 1 in 4 stinks, but 1 in 2, I feel pretty darn good about what I've done there. Again, because I think about 70% is a 5. It's the basement for a 5. So feel pretty good if I could do, get a correct answer for half and then 50-50 the rest. That's great. You know what I'm saying? Who's next? Let's hit some more of these. But Paulo, you're good with what I did here?
Yeah.
Notice that I didn't even worry about like the height is 3 times its base or any of that stuff, like how to really set up the integral. I didn't really care because I have the correct setup there and I just looked at the differences between the things. So
I didn't get to the x2, x1.
Yeah, so like just simplify things. Like look at it and be like, all I really need to know is what this length is. This length is this x coordinate minus this x coordinate. Oh, it's got to be subtraction in there because the functions are both 2 positive things. Like that cuts out so much time from having to like figure out what the expression is and all that stuff. And the picture did most of my lifting for me. Like having a good picture to look at and be like, okay, what am I really doing here? What is it telling me? Like super valuable. And they were nice enough to give us functions that like, how to draw the picture without thinking about it. So, and again, like the y equals 2x, I didn't plot points. I just kind of like line with a positive slope. That's all I really need to look at. So, who's next? Let's do some more. These are good ones, though, that you guys have asked about in terms of like, what is the key thing? Is there a way to get around it without remembering the key? Or here's a question that like we can answer without having to do the whole question. Like these are great little test strategies that we're talking through. So I think this has been really productive so far. Let's keep it going, though. Yeah, Violet. 28, sure. All right. An isosceles triangle with legs of length s has area 1/2 s squared. At the instant when s is square root 32 centimeters, the area of the triangle is increasing at a rate of 12 square centimeters per second. At what rate is the length of the hypotenuse of the triangle increasing in centimeters per second at that instant? So when you read this question, what type of problem is this? It's a related rates problem. Also, when I read this question, it's asking about the hypotenuse. The area formula has no hypotenuse in this. So I know I'm going to be using another equation somewhere in this, whether replacing a variable with it, probably not though, because we're told about ds dt, or I'm going to be using a second equation and solving for some part from the first equation to use in the second equation. So I would start now by writing down what we know. So we're told that dA dt, when s is equal to the square root of 32, is equal to 12. So I'd start by then taking the derivative of my equation with a in it to get an equation with dA dt in it. So with that equation, if I plug things in, I can solve for ds dt. So it's asking us about dr dt. Again, when s is square root 32. So to do that, I'm going to use the Pythagorean theorem. So I have like s squared plus s squared equals r squared. And then I'll do the derivative of that. So I have 2 square root 32 times 12 plus 2. Oops, not 12. It's 12 over root 32. Plus 2 root 32 times 12 over root 32 equals 2. And I don't have an r here, right? But that's the last thing I'm going to need. How am I going to find the r? Yeah, just the Pythagorean theorem, right? We're told s is root 32, so r is 8. So if I do that, I have 24 plus 24, 48 equals 16 dr dt. So I divide both sides by 16, and I get 3. So this would have been, I think, a more time-consuming problem. This is a place where, like, there's no shortcutting around it. All I have is 3 answers. The 3 answers don't tell me a whole, or the numeric answers aren't telling me a whole lot. I mean, if I were to think about it for a moment, it's if it's asking about the rate in which the side is changing, I would think I could probably eliminate C and D just from jump because of how huge those numbers are. But that's probably as far, and 50-50 is not bad, right? Without having to do any work, if I can 50-50 it. Right, if the area is changing by 12, how's the hypotenuse going to be changing by 48 units? Like, that seems unlikely, right? Or square root 32 is like, is that like 6 units? That's a lot for the area. Like, I would think if the hypotenuse is changing by 6, the area's got to be changing way more than 12, right? That's really stretching things out. So probably those two right away I feel are pretty unlikely. Even if I'm just trying to, like, remember how to do this, I just need to guess. You know, like, think about the size of the numbers and what's going on, and usually you can make an intelligent argument or intelligent guess. 3 over 4 seems a bit small to me. If I were just guessing with no work, I'd probably would have picked the 3, but I know how to do it, so I'm not gonna guess. But if you're in a time crunch situation, or you're just like, it's not coming to me right now what I need to do to start this or how to do this, like, think about it physically, like, reason it out. Like, this is a geometric problem. It has a picture that you can imagine in your head what's going on, and you can probably get to the right answer, or at least a 50-50, by just kind of thinking about what physically this would need to look like to eliminate some guesses. And that's great. If that's the best you can do in 2 minutes, 50-50s are not bad. That's a win, you know? Violet, you feel, were you good about how we read the question? I knew that I was going to have to use a second equation, right? Because there's nothing in the equation for area with r in it. The other thing you could have done is taken this and substituted, or like solved that in terms of r, and then drop that into or substitute the S in terms of R and then drop it into the original. I think this is easier. I think the arithmetic is easier. You have less radicals on top of radicals rolling around in there. But it'll do. '29's I thought was the easiest one on this practice, is it's a pre-calculus question, just asking about vertical and horizontal asymptotes on rational functions. That's a gimme, right? Denominator equal to 0 causes vertical asymptotes, and then you're just using your degree of the numerator over degree of the denominator rules for horizontals. Pretty nice. Anyway, who's next? What else? Is this, you feel like the little, me trying to talk on a more meta level about like test strategies and how to, if you don't know what to do, what can you still do? Like how to think through a question if you're not, like I just forgot how to do this. What can I do with it if I forget? Like to eliminate down some guesses. I think is hopefully really helpful, something we haven't done a lot of. But this is, I think, is the time to spend when the test is approaching here quickly. What's next? Who's next? Are we ready to move to the next section on the calculator part? Should we do that? Okay, let's go. Calculator it up then, my dudes. So that's section 1B. Here you get 3 minutes per problem, so you can be a little bit more patient. I don't know why they give you more for the calculator problems. Maybe it's because you occasionally run into, like, when you try to graph an integral, it just takes, 5 minutes for the thing to graph. And then again, for these calculator active questions, probably 50% of them are still, the calculator's kind of useless, right? If we notice this, that 50% or so of the questions could have just as easily been in part A and would have made no difference to what you would have done to approach it. Now, the other 50% are ones like you dead want the calculator for, because, boy, it helps. Or you couldn't do it without it at where we're at. But who's ready? Got some questions from this section. Yeah, Elena. 79. Sounds good. Well, this one has a lot of words here. All right. A file is downloaded to a computer at a rate modeled by the differential equation f of t, where t is the time in seconds since the start of download, and f of t is measured in megabytes per second. Which of the following is the best interpretation of f prime of 5 equals 2.8? So I would start by just identifying the unit. Since it's the rate of a rate, the unit for f prime should be in megabytes per second per second. So the first thing I'm going to do when I read this is I'm going to eliminate all the options that are the incorrect unit. Okay, so it says part A says, or option A says, at time t equals 5 seconds, the rate at which the file is downloaded to the computer is 2.8 megabits per second. Wrong unit. At time t equals 5 seconds, the rate at which the file is downloaded to the computer is increasing at a rate of 2.8 megabits per second. The unit at least matches there. So we'll keep B. Part C says over the time interval 0 to 5 seconds, 2.8 megabits of the file are downloaded to the computer. That's like doing an integral. And D says over the time interval 0 to 5, the average rate in which the file is downloaded to the computer is 2.8 megabits per second. Wrong unit. B is my only option. All I did was worry about the unit that it had to have, and I was able to eliminate down to one option that is the correct option. Elena, does that make sense as to what I did there? Yeah, so again, like, for a question like this, I'm just going to worry about, like, the right answer is here somewhere. The differences between these statements are subtle. I'm going to pick one thing that is different that I know the correct answer has to have and start looking for that. And if I can eliminate 2 or 3 choices, well, 2 choices, 1 choice or 2 choices, I feel great. If I eliminate 3 like I did here, I'm done and I just move on. But again, like, I'm not trying to write out what this would mean in words. I'm just going to be like, what does the correct answer have to have? Well, this has to be the unit. Let's eliminate everything that has the wrong unit, because it doesn't take anything to do that. Like, all I have to do is read. Elaine, does that feel okay? Okay. Again, like, kind of a scary question with a ton of words, but in a way was if you knew what to look for, or if you looked for the right thing, you know, pretty easy. Who's next? And again, this is a great question where you can bank some time, potentially, right? Like, should not have taken 3 minutes to complete this if you looked for it in this way. That's wonderful. Let me save 2 minutes for something else where, like, I really need to grind through some algebra or the calculator's going to take forever to do this. Or I just keep fat fingering the calculator and goofing it up and not getting any of the answers on there. It's like, I think I'm doing this right, and now I'm stuck trying to sift through my work looking for my mistake, which is always time consuming, you know. So who's next? What else? Yeah, Emily. 77, sure. Okay. It says let h of x be the antiderivative of this expression if h of 5 is pi and h of 2, or then h of 2 equals what? So this is a very common setup. So the way that we want to handle this problem is that these are going to become my bounds of integration. And using the fundamental theorem of calculus part 2, I can state this. So h of 5 is just pi. So if I subtract the pi over, I have like negative h of 2 is equal to the integral of whatever minus pi. And then if I divide both sides by the negative, I have pi minus that integral. And that is just going into my calculator now. Does that feel okay? So this is a super common setup. I would be shocked in the calculator section if you do not have this exact question with like a different function and different values or whatever. But this is a super, super, super common presentation. It's a nice way to check that you know the fundamental theorem of calculus part 2, and know how to use like a definite integral, like what that really means. But that's the whole setup. So this is a type of question that you should expect to see, and one that if you know what to do is quick, right? The longest part is going to be typing it into your calculator. If you know, if you recognize what you're doing here and what the workaround is or how to work it. You know what I mean? So again, like I've looked at a bunch of these practice or a bunch of these old AP exams. This type of question comes up over and over and over again. I would be surprised if you do not see almost this exact type of question. And it would be placed in the calculator portion, whether it's as a free response question or as a multiple choice question, or possibly in both. Emily, does that feel good on the algebra? And again, if you get to here, like should be good, right? And even if you were uncertain about the algebra, then you could literally like do this in your calculator, graph this as y1, and then do pi minus x as y2, and just look for an intersection. That would work. I think when we type it in, this is the one that you get as B. That's what I have written down on my key. Are we good with how to get that into our calculator, Em? Okay. I just assumed that. I just realized I'm like, I should check to make sure we're good with doing a definite integral on our calculator. I assumed we would be, but you know what they say when you start assuming things. Okay. Next one. What should we look at next? Sure, 86. All right. The twice differentiable equations f, g, and h have second derivatives given above. Which of the functions f, g, and h have a graph with exactly 2 points of inflection? So when we talk about point of inflection, we're talking about the second derivative changes sign, right? So you could graph on your calculator each one of these and look for places where the graph crosses the x-axis. Now it has to cross. It can't just hit and bounce. It can't have have a bounce. That's not going to change sign. That just gets it to 0. But that's all you're looking for. So this could be also though a no calculator problem. So if I approach this if I ran into this in the no calculator section, if I look at this first one, this has x-intercepts at 0, 1, and -2. And because it's and the degree of it is even, right? It's 1, and then 2, and then 3, so that's degree 6. And its leading coefficient is positive. So I know like both ends are going to point up. At -2, since that has a multiplicity of 3, I know it like goes through the x-axis. It's got to come back up to the 0. That has a multiplicity of 1, so that's going to go straight through. And then it has to come down to the this 0, but that has multiplicity of 2, so that bounces. So if I look at this, this is going to have 2 points of inflection. So I know that those guys are not possible because F certainly fits the criteria of having exactly 2 points of inflection. If I do G, again, I have x-intercepts at, so I've just shifted this graph up 1 unit, right? So if I do that, it's going to look like that, right? Still have 2, so that one works. So F and G both work. If I do H, that's going to shift down 1 unit. Oops. And that one doesn't, because now I have 4 inflection points. Now, I wouldn't have done this by hand in a calculator section, but it could be done by hand. Like, you did not need the graph and calculator for this. You can get the graph of F or F double prime with what we know from, like our pre-calculus course or Algebra 2 course even, would have been enough to do that. Now you would have had to remember, which would have been the multiplicity thing and how those x-intercepts hit. Like, that's asking a lot. I would have graphed it for sure, but that'll do. And just for the record, when I graphed this, I would have just typed F double prime into Y1, and then into Y2, I would have done Y1 plus 1, and then Y1 minus 1, so I didn't have to type all those symbols again. Just trying to think of ways to save myself, 30 seconds of like number punching. And then I want to make sure when I graphed them one at a time and not all 3 of them at once. So I'm like confused as heck about which one is which. And have to go back and like regraph the thing after it's done and just trying to think of ways to save time. Does that feel okay though on what to do with that?
I just forgot what
Yeah. And again, that's the key, right? If you didn't remember that, I don't know what you're going to do. Had to have it. All right, next up. But again, like, worth talking through, like, how you could do that by hand. Although I wouldn't think that they would make you do that with no calculator. It's definitely doable with what you should know without a calculator, although it's a tall ask. Okay. Well, I'm going to talk about something here for a minute while you guys are kind of sifting through things. So, reminder that the format for your AP exam is mixed. So the multiple choice is going to be done on your tablet, and the free response is going to be done in your on paper. So to do the multiple choice part, you have to have the Blue Book app on your tablet, and your tablet needs to be able to like sustain a charge long enough to finish the exam. If you don't have the Blue Book download anymore, I put on in the announcements, some stuff about how to do that. Or if you're having trouble with like, my stuff doesn't like, my computer's battery lasts 6 minutes and then it's just, make sure you take a trip to IT and kind of get that squared away, whether they need to have a loaner tablet set up for you or whatever. Does everybody still have that Blue Book app downloaded? I think you've needed it for other courses. There's also a like a practice for the multiple choice for the AP Calc. So if I go to my Blue Book and I just sign in, now my end, I can't do some of the stuff that you can because I'm not a student or whatever. I think it's that. Oh boy. It makes sense, guys. Nope, that's not what I wanted. Try that one more time. Now, I suspect if you guys all try to do this at once, that was what I meant to type in. It'll not work great, but there is like a full-length practice that you can do on the computer just to get used to. Good. Just get used to what the format's going to feel like, or doing a multiple choice test on the computer as opposed to by hand. I would suggest, like, when you're studying, at least go in and do a little bit of it to get used to that format and what that's going to look like. I assume you'll get scratch paper in addition, because most of these problems you can't do in your head, I would think. I mean, I couldn't. But they have this stuff available for you. So I just wanted to get a minute and say that. So I wanted, is that cool for you guys? Figured we should make mention of that because it's a nice resource to have. The other thing I would say is that remind you guys that you've already done the hardest part of the course, right? Like, you sat in here for 9 months. We did a lot of stuff. We did a lot of really difficult things. You've done the hardest part of the course, the most time-consuming part of the course. That you've invested a lot already in this. And now I know some of us are, probably thinking that, like, it doesn't matter. I got into where I'm going. Like, I don't think I can do that well. I would encourage you to still prepare and to still really try. A good score here can be a course credit, which is like $3,000 to $4,000 for a lot of places. If I told you that I would hand you $3,000 or $4,000 cash if you could do well on this, would you try really hard to do well? Think about it that way. Like, it's a lot of money for being able to do something that you've already kind of learned, right? You need to go back and review and sharpen up and make sure that you have things memorized that you have to have memorized, right? So should we talk about the stuff that I would want, that if I were in your shoes, that I would make sure that I've memorized? So I would want stone cold my derivative rules and my antiderivative rules, particularly the trig stuff and the inverse trig stuff, the logarithms, like the exponentials that aren't e, like the derivative of 2 to the x, is that 2 to the x times the natural log of 2, or is it divided by the natural log of 2? Like, I want to have that stuff stone cold memorized, have to have it. After that, I'd want to make sure I have my major derivative rules. So, like, product, quotient, chain. Got to be able to use those in context. So like the quotient rule is that bottom times the derivative of the top minus, top times the derivative of the bottom, or is it flipped? Like you got to have it. Like you got to have it stone cold locked. I want to have my intermediate value theorem, mean value theorem, extreme value theorem. Those are things that I'd want to have memorized, at least the conditions that I need and the conclusion that I can reach from them. I don't need the words all memorized, but I need to know what do I need to have to use this and what does this allow me to say. I need to know that, even if it's just in my own words, that's fine. That's good enough. I would want to know my definitions. So definitions for like continuity, or if something is what kind of discontinuity it is, whether it's a jump or an infinite or a removable. Like how would I show that using limits? Know how to use L'Hopital's rule, although you probably won't see anything that's not a fraction or a product. So like we did stuff that was more difficult than that in class. I wouldn't expect to do anything that's not already a fraction or a product where it's easy to write it as a fraction. Like e to the x times x, you can just write as like x over e to the negative x or whatever. I'd want the limit definition for the derivative and integral and kind of how to use that. Again, the limit definition of a derivative, you will not have to use, but what'll happen is you'll have a problem where it'll say, what is this limit? And it'll be the limit definition of a derivative. It's like, oh, all I'm really doing is taking the derivative of, like x squared plus 5x plus 7. But to do the limit definition of that is like a nightmare. But to recognize that, all I need to do is the derivative of that takes a second. So you just have to know it enough to use it. The same thing with like the limit definition of an integral. You just have to know it well enough to like, can I pick out which one of these presentations is the correct one? Because that'll happen on occasion. They'll give you a problem where it's like, like which of these is the same as this integral? Or the reverse, they'll give you the limit of the Riemann sum and ask you which integral is the same as this one. And then like your just major vocab, right? Like, like the like inflection point, or how to find a min or a max. Does it make a difference if you're on a closed or open interval? Like what are the different ways you can find a min or a max? Like first derivative test, second derivative test, like that kind of stuff. For the most part, first and second derivative test, either one will work. I would be shocked if they had a presentation where the second derivative test is really the only one you could use. Would most likely only happen in the context of like a implicit function. So something where the x and y's are on the same side. If you have like x times y plus x squared minus y squared equals 7, like doing a first derivative test on that is not really possible because you have to pick x's and y's to find the derivative now. That doesn't make life very realistic. But that's the big stuff, I think. So again, like your value theorems, your derivative and integral rules, like remembering some of the algebraic tricks you can use to make an integral realistic to deal with. If you have like x squared plus 7x plus 5 all over x, to just write that as 3 separate fractions, and then it's a piece of cake to integrate. Or using negative exponents to make something from a fraction into just like a power function that's, again, easy to integrate or differentiate. So remembering those little tricks. Some of our limit tricks, but L'Hopital's the big one. right? Direct substitution, unless you get something that's indeterminate, and then you L'Hopital it until you get something that you can deal with, is usually good enough. Occasionally there's other tricks that you might need to use, but I'd find it unlikely that you run into anything that can't be done doing that. But I'd also want to look at, like, how do I do limits with a graph, right? How do I look at a graph and know whether the limit exists or not, or what the limit would be, or if when does the derivative exist or not, right? What are the 3 ways the derivative doesn't exist? Discontinuity, a corner, or a vertical tangent, right? Those are the 3 ways that, or 3 times the derivative would fail to exist. Again, like, you knew that at one point really well, whether you remember it when you need it. That's why you want to go through things and study and look through the practice exams and be like, oh, why was this so hard for me? What am I missing? Oh, I forgot that this is a thing that I have to use. And that's the point of doing these things, is just to, like, make notes to yourself of the stuff that, like, oh yeah, it's something I have to remember. Oh yeah, that's something I have to remember. So as I'm working through any additional practice tests, I would keep, like, a log of things that, like, ooh, I didn't remember that, I had to look that up, or like, ooh, I didn't remember that derivative rule or that integral rule, or I forget what the mean value theorem says. Like, make a list of stuff to write down and just, like, read through it once a day, you know. As it goes to, like, test preparation, my best advice for you is do a little every day. Cram session, I would stay away from crams. I would try to do 30 minutes a day starting now to the test day. Make a note of what you've done, anything that was, like, hard. Make a list of, circle back to, make a list of things that you had to look up, review those, you know, take 15 minutes at the end of the day and just kind of read through that again, just to kind of start committing some of those things to memory that you come across that you didn't have when you needed it. But it's, I think, a little practice every day goes much further than one gigantic cram session the day before. So just make it part of your schedule, you know, like, get up, have some breakfast, do 30, 40 minutes of stuff, and then go on about your day, you know, go do what you want to do for the rest of the day, and you're done, you know. If you chip away at it, it becomes much more realistic to tackle than trying to do it all in one day. All in one day feels like climbing a mountain. We're just going for a walk. You take a little walk every day, you end up both climbing that mountain without even realizing it. You know? Can't think of anything else. Oh, I guess I have one more question for you guys. If you checked out a textbook from me at the beginning of the semester, at some point I would like that back. Now, you can wait till the test day and then come find me before or after the test and give it back. That's fine. But if you want to get rid of it, you're like, I got everything I need. I got the OneNote. I got my notebook. I don't think I need the textbook anymore. You can get rid of that and give it back to me whenever. If you return it to me and I'm not here, just get, like, a sticky note or a sheet of paper or something and, like, write your name on it so I know who, or send me an email and let me know, you know, so that I know who brought this back. But if you checked out a textbook from me, find it. Step 1. Step 2, if you're done with it, when you're done with it, make sure you get it back to me before graduation. Okie dokes. I think that's it from me. I don't know that there's anything else I have really to say, unless you guys have specific stuff you want to talk about. In general, once you guys are done, I lose my first, fifth, and eighth hours. So if you have questions, you want to come in and talk to me, like first, fifth, or eighth hours should be easy for me to do. Send me an email to make sure that, that I'll be there. But if you want to talk or go through something, or just like, I did this stuff, can we go through this thing, and this thing, because I wasn't sure or whatever, happy to do that. Okay? Yeah, Jen, what's up? Of course. I liked your artwork, by the way. I saw it in the courtyard, or the lobby, whatever, the triangle. What do we call that place? The place with all the arts. Triangle. We'll call it the triangle. All right. Cool. Congratulations, guys. You did it.